So we then go ahead to look at our first example. Okay, first example. So we consider the matrix vector B, which is in terms of this expression. Using the House order reflection, we want to determine the QR factorization or decomposition. So first of all, we choose our x1 to be the first column vector, and then we find the norm of it. We use that norm 2, and the norm 2 we happens to get row 3. From the previous slides, we realized that we can obtain our u1 to be the x by this expression we have here. This is our x1, and then our norm times what? Our standard basis vector, which gives us rise to this nice vector that we have here as our u1. And from u1, we go straight ahead to find our House order vector v1, which is the whole of this this vector here. And then from having obtained our v1, we then substitute it into the House order reflection formula and give us our reflector that we are looking at. So with this reflector that we have seen here, if you multiply it by itself or twice of it, will give you back will give us back our x1, which tells us that our H is an idempotent matrix, and the transpose of it will still be the same thing. Then we'll continue with our solution finding. We pre-multiply our original matrix, which is B here, times our H1, and then this gives rise to our R1. If we consider our R1 is gradually getting is gradually helping us to obtain our right upper triangular matrix. So for computational purpose, we assign our H1 to our Q1. Okay, we'll call it our Q1. Nothing changes, nothing is destroyed. So we now want to focus on our R1. For the next step, we want to obtain a right upper triangular matrix. But what we have obtained here is not. So it means we have to do something about it. So now we are going to now focus to delete this very one, that's 0.4226. We want to do something to it so that it runs to 0. That's the beauty of mathematics. So watch what we are going to do. Since we don't want to alter anything here, we will assign, considering the whole of this column, we will assign 0 to this very matrix, this very element here. That's 2.8868, which we choose our x2 to be in terms of this. So in place of 2.8868, we have 0 here, and then the rest. So the transpose of it, and then we find the norm of it, which gives us this scalar, this very scalar that we have here. And from u2, to obtain our u2, we have seen this expression here, we just substitute, and then eventually we get this very vector that we have here. Okay, so having obtained our u2, we now go ahead and plug it in, and then eventually we get our u2, our v2. And from our v2, we can now go ahead to get our House order reflection again. Our House order reflection vector again. Sorry, House order reflection matrix again. So from here, we now continue. So we also pre-multiply. Multiply from the left, we call it pre-multiply. We pre-multiply to our R1. We have seen this one is R1. And our R1, with the help of our H2, we happen to get our R2, which is pretty nice. And from our R2 happens to give us a right upper triangular matrix. Are we done? Somehow. So once we happen to obtain our R2, we have to also do something to get our Q2, because we want to obtain a QR decomposition. So from here we already, from our previous calculations, we obtain our H1, and then when the subsequent ones we also obtain our H2, so we post multiply. That's H2 to H1, and then which give us this our H1 and this our H2, and eventually we obtain our Q2, and our Q2 is the orthogonal matrix that we are interested in, and our R2 is the right upper triangular matrix that we are interested in. So if your Q times your R, this matrix times this one, will give you back your original matrix. That is the matrix B. We consider the second example, okay? This one is not a square matrix, and we'll see how this one also goes. It follows the same procedure, but with this one, let's dive into it and look at it into details. So we also consider the first column vector, which is our x1 here. We find the norm of it is 2. We have seen this one again before, and then we just substitute, give us our nice vector here. We then go ahead to find our v1, which gives us our v1, like we said, is the householder vector. And our householder vector for the first process is the whole of this. With the help of the householder vector, we happen to get our h1, which is the whole of this expression that we have here. We post multiply our h1 to our B, our original matrix, which gives us our R1. So meaning we have deleted 3 zeros at the goal. So we then go ahead, like we have seen in the previous one, we want to do something such that we'll be able to get a right upper triangular matrix, if possible. Okay. So we consider this whole column here, but we have to notice something, that we don't want to alter the 3 here, so we have to do something. In place of the 3, we'll have 0. So let's watch how it goes. So from here we have our 3 zeros, we find the norm of it, which is 5. And then we find our U2, which is the whole of this thing here. And from U2, having obtained our U2, this our second, okay, this our E2 is our second standard basis vector. That's 0, 1, 0, 0. And then we get our U2 here. And from U2, we also obtain our V2, which is the whole of this expression. We substitute it into our H formula, or the householder matrix formula, and it gives us our H2 formula nice here. Then we also multiply with the R1 that we have seen previously, and then it eventually gives us our R2, which is bingo. So from here we should have continued with the process, but we happen to see that with this, just in 2 process, we happen to obtain a right upper triangular matrix that we are interested in. That is from here. We have seen that all the diagonals are non-zeros, and then all the numbers beneath the diagonals are zeros. So like we wish to have done the third process, but based on having obtained this, then we can't go again. We just conclude from then. So we, considering our H2, we post multiply to our H1, and eventually give us our Q2. So this has bring us to the end of, and this is our R2, or our right upper triangular matrix under consideration. this has brought us to the end of these tutorials. If you show interest in it, please like, comment, and subscribe to this channel. Thank you so much. Bye.